Okay, I'm good. You guys ready? 1, 2, 3, 4, 5 of you?
Yeah.
Take out your formula sheets while you're waiting. I'm giving you 5 problems tomorrow, so they take a while.
All tennis players meet in the high school gym after school.
Yes.
And classes for junior boys girls track and field will be canceled for today. There will be practice after school on Friday. Thank you.
Why does it look so weird?
Is that better?
It looks weird. Okay, ready to go, you guys? Did you push record?
Yeah, it's already recorded. You're all good.
Okay, 7.4 on the back side of your formula sheet. There are 1, 2, 3, 4, 5 double angle formulas. There's the sixth one. Tangent of 2x equals sine of 2x over cosine of 2x. These right here are on the top right corner. Locate those on your formula sheet. Top right hand corner, flip your formula sheet over, and these are the double angle formulas. Sine has 1, cosine has 3, so you have your choice. Tangent has 2. This is the one they give you. This is mine. I kind of came up with this. This is the one I use. It's quicker. I'll tell you why it's quicker.
It's Cho's equation.
These are called the half angle formulas. There's one for sine, one for cosine, and I don't teach the tangent. Is tangent on there? Yeah. But it's really confusing because you have to multiply by the conjugate, and it's just
Not fun.
it's not fun. So we're just going to work on these, how many, 8 or 9 formulas. These are the same.
You can use them the same way.
These
Just a different way to
three
write it.
are the same. These 3 are this one. These 2 are the same. This is the only one that you have no choice. You have to use this formula. These you don't have a choice. There's only one. Cosine and tangent you have choices. I don't know why, but they're giving you lots of choices. What you're going to find out tomorrow, 7.5, remember doing 7.2, you guys? You guys remember doing 7.2 on changing things to sine and cosine and using all those formulas? We're doing it again tomorrow, but now we even have more formulas, like this. Cosine squared x take away sine squared x is cosine 2x, but what happens if this would have been a plus sign? It equals 1. So if it's a plus sign right here, it equals 1. If it's a minus sign, it equals a totally different formula. And that's why it even gets more confusing tomorrow, because we keep adding more and more formulas to our chapter. Okay, here we go, next page. Okay, so part 1. Why are we learning these half and double angle formulas? Just like remember doing the sum and difference formulas on the front page? Back in the olden days, they could do 17 popular angles, right? But sum and difference formulas, if we wanted to find the sine of 75, we could use a calculator nowadays to get that answer, right? But back in the 1700s, could you find the sine of 75? No. What do they have to do? They have to do the sine of 30 plus 45, right? And then they could draw a picture to come up with the answer. It's the same concept today. Do you know right offhand, without a calculator, what the sine of 22.5 is? Would you guys know the answer without a calculator? No. But guess what? We're going to use a formula to come up with the answer without a calculator, right? So, we're going to use the half angle formula. The sine of something divided by 2 has to equal 22.5. What is that something? What is that number divided by 2 would give you 22.5? 45. Do we know 45 degrees? Is that a popular angle? The first 3 problems today, they're trying to come up with a number that some number divided by 2 would give you 22.5. All you have to do is take this number and double it, and it'll give you that number, correct? Right? Okay, so I'm going to use plus or minus the square root of 1 minus the cosine of alpha divided by 2. We're doing the half angle formulas. They're on the left-hand side of your formula sheet on the top page. We're doing the sine of 22.5. We don't know 22.5, but we know that 45 divided by 2 is the same thing as 22.5, right? So, ready to start putting things in? Plus or minus, this will take 8 steps. That's why these start time consuming. Plus or minus the square root of 1 minus the cosine. It'd be really silly, doesn't this stand for angle? It'd be really silly to put 22.5. We don't know 22.5, but we do know 45 is going to go in there. Divided by 2. Now comes the simplifying part, common denominators and all this fun stuff. Plus or minus the square root of 1 minus something over 2. We need to know what the cosine of 45 degrees is. Some of you know what the cosine of 45 degrees is because you're getting better and better. Some of you need to go over here and make a 45-degree triangle and label it 1 square root of 2 and figure out what the cosine is. Cosine is 1 over the square root of 2, which is the same thing as the square root of 2 over 2. Most of you knew that it was the square root of 2 over 2 without even drawing a picture. Okay, about 5 more steps because of the common denominators. Okay, here we go. Plus or minus the square root. I need to find a common denominator in the numerator. Isn't it going to be 2? So isn't my 1 going to change to 2 over 2 minus the square root of 2 over 2 all over 2? Which makes plus or minus the square root of 2 minus the square root of 2 all over 2. I just put my numerator together. Still all over 2. Then I'm going to write it as plus or minus the square root, and I'm going to put 2 over 1 so that I have a fraction divided by a fraction, right? So I'm going to rewrite 2 minus the square root of 2 over 2 times what? 1 over 2. Keep going. Plus or minus the square root. 2 minus the square root of 2 times 1 is 2 minus the square root of 2 all over 2 times 2 is 4. And then in college algebra, I taught you that if you have a huge radical and you have a fraction, to break it up into 2 different radicals. Plus or minus the square root of 2 minus the square root of 2 all over the square root of 4. But there's a rule in math that says you can't leave a radical in the denominator, and everybody knows that the square root of 4 is 2. Not done quite yet. I bet you've never done the square root of 2 minus the square root of 2 root inside a root before. Okay, circle this, star this. Everybody gets this wrong on the test, so hopefully you can remember, because for some reason every year they get this wrong. You need to decide if it's a positive or a negative answer, right? You need to go all the way back up. Look at the original problem. The original problem is this right here. The sine of 22.5. Which quadrant are you in if you want to find the sine of 22.5? First quadrant. Is the sign positive or negative in the first quadrant? Positive. So the answer is going to be positive. If you put this into your calculator, which would take a little bit, the square root of 2 minus the square root of 2 over 2, you get a really weird decimal. Do you think if you plugged in the sine of 22.5, you'd get the same weird decimal in your calculator?
Mm-hmm.
Right? So, okay, let's do another one. Some people, there's some people in here that can probably go from here to here without this step. but I like showing all my steps. I mean, some people know that 1 is the same thing as 2 minus the square root of 2 all over 2 and skip the step. It's up to you if you want to skip it, but I wanted to show you how I got to every step. Got it? Let's do one more of these. Last one, we'll do a cosine one. What's the cosine of 19 pi over 12? Well, the first thing I'm going to do is change this into degrees. How do I change this into degrees? Go back to the beginning, take 19, multiply it by 180, divide it by 12, and it turns out to be 285 degrees. Do we know what the cosine of 285 degrees is? No, it's not a popular angle. So we're going to use the half angle formula, the cosine of something divided by 2 to come up with this. And all you have to do, even though it's called the half angle formula, you're really going to take 285 and multiply it by 2, or double it. What's 285 times 2? 570. We know 570 because all we do is take 570 and subtract it from 360. Remember doing these coterminal angles way back at the beginning? It's going to end up being 210. 570 and 210 are the same number. So we can use 210, because we know 210, to help us get to where? 285. I'm going to bubble this in. This is the original problem. What is the cosine of 285? I'm going to go plus or minus the square root of 1 plus the cosine of alpha or theta, or whatever you want to use, over 2. I'm going to keep the plus and minus the square root of 1 something over 2. We need to figure out, are we plugging 285 in for alpha, or are we going to plug 570 in for alpha? We're not going to plug 285 in. We don't know it. We're not really even going to use 570. We're going to use its little alter ego 210, aka 210. So we're going to do plus the cosine of 210. I'm going to use 570. But 570 is the same thing as 210 degrees. So keep that in mind. Because 570 divided by 2 gets you 285. Okay, now we're going to run through this. Plus or minus the square root. I'm going to draw myself a picture. I almost need a picture. 570 and 210 are right here. Yep, they're in this quadrant. This is 30. Opposite of 30. I'm going to erase this. Opposite of 30 is a negative 1. This is a negative square root of 3. And this is 2. So, 1. What is the cosine of 210? It ends up being a negative number. So that positive isn't going to be positive anymore. It's going to be a negative square root of 3 over 2. All over 2. So instead of working with 2's now, you finally get at least a 3 in the problem. And we're going to go through the whole simplifying this. So here we go simplifying. Again, what did I do? I just found the cosine of 210. I drew myself a picture, found out that it's negative. That's why plus or minus the square root. Change this to 2 over 2 minus the square root of 3 over 2, all over 2. Plus or minus the square root of 2 minus the square root of 3, all over 2, but some of you know that when you do it all over 2, there'd be a 4 down here, right? Some of you know that this is going to end up being a 4, but I'm going to prove to you, 2 minus the square root of 3, all over 2, make this over 1. This should end up being a gigantic radical. And it's going to be gigantic radical plus or minus 2 minus the square root of 3 all over 2 times 1/2, which ends up being plus or minus the square root of 2 minus the square root of 3 all over 4. College algebra, I taught you to break up the radical into 2 separate radicals, plus or minus the square root of 2 minus the square root of 3 all over the square root of 4, but the square root of 4 is 2. So if you plug this into your calculator, or if you plugged in the cosine of 285 into your calculator, they should come up with this weird decimal, right? We need to figure out if it's a plus or a minus though at the end, right? Plus or minus. Circle this, star it. We need to decide if it should be plus or minus. Here's the question. Do we go back to 285, the original angle, or do we use the 570, or do we use that 210 one? Because if you use the 210 one, you're in the third quadrant. 570 is in the third quadrant. But where's 285 located? In the fourth quadrant, right? But we're trying to find this answer, right? In the fourth quadrant. Is cosine positive or negative in the fourth quadrant? Cosine positive or negative in the fourth quadrant? Positive, right? So I'm going to erase this. It's not a negative answer. It ends up being a positive answer. Final answer. These are called the half angle formulas. Basically, you're going to always end up having the square root of 2 minus. This could end up being a 2 or a 3 divided by 2. So, moving on. Okay, last part. Now we're going to use the double angle formulas. These are easier than what we just got done doing. The bad thing about this one though, there's really 3 things they want you to do in this problem. They want you to find the sine of 2x. They want you to find the cosine of 2x. And they want you to find the tangent of 2x. There are 3 parts to this. Last problem, there was only 1 part. So, the first thing I'm going to do is write a formula down for each one. There's only one for this one. Top right-hand corner, there's only 2 sine of x, cosine of x. You have 3 choices for this one. I'm going to use the first one. Cosine squared x minus sine squared x. Tangent, I'm not going to use the one they gave you. I'm going to use the new one that I have. Isn't tangent sine over cosine? So isn't sine 2x cosine 2x? The one that I came up with, I'll show you there's a flaw in mine, but I'll tell you why it's easier and why there's a flaw in mine and why they don't even show this one in the book. This one they don't even show in the book. They only show the one that's above it. Okay, ready to go? First thing you're going to do is draw a picture in the first quadrant. So here's my little picture right up here. My triangle's in the first quadrant. So draw a picture in the first quadrant. And I'm going to label my sides. And I know that they gave me the sine equals 2/3. So I know that that's opposite over the hypotenuse. I can find my other side by doing the Pythagorean theorem. 9 take away 4 is 5. It ends up being the square root of 5. All I'm going to do now is substitute in. Ready to substitute? To find what's a double angle answer, all you do is put 2. In place of the sine of x, I'm going to look over here, and sine is 2/3. It was already given to me. Cosine of this picture is adjacent over hypotenuse, which is the square root of 5 over 3. Final answer. Whenever you're multiplying, you do not have to find a common denominator, so all you have to do is multiply across. 2 is really in the numerator. 2 times 2 is 4. Square root of 5 over 3 times 3, 9. Final answer. But now we have 2 more. They want us to find cosine of 2x. So I'm going to show my work. The first thing you're going to do is figure out what the cosine is. The cosine is the square root of 5 over 3, but what do you have to do with the square root of 5 over 3? You've got to square it. Minus, the sine is 2/3. I'm not going to say what it is. I'm going to square it later. Square it. I'm going to put it right here. Square root of 5 times the square root of 5 is 5. 3 times 3, 9. Minus 2 times 2, 4. 3 times 3, 9. Yes, you do need a common denominator when you're subtracting, but we do. 5/9 take away 4/9 equals
1/9.
1/9. Okay, this formula down here to find tangent of 2x, why I came up with this one is, don't we already have the answer to the sine of 2x?
Yeah.
Isn't it right there? Don't we already have the answer to the cosine of 2x? Isn't it right there? So can't you just put them right on top of each other then? And I think it's quicker. I think it's a quicker formula. And then, flip them. 4 squared of 5 over 9. Change the division sign to multiplication. Flip it to 9 over 1. The 9's cancel out. So what is the tangent to x equal? 4 squared of 5. I could show you that the one that they gave you would come out to be 4 squared of 5, but it would be longer. It'd be harder. What's my flaw, though? My formula compared to the book's formula. Why is there a flaw in my formula? You could get one of these two wrong up here, and then your tangent is obviously wrong, right? If one of these is wrong, then your tangent is wrong. That's the flaw, and that's probably why they're not giving you this formula. The other formula, isn't it 2 tangent of x over 1 minus tangent squared x? You don't need to know sine or cosine to get the answer. You just need to know what tangent is in the picture. Do you want me to do it the other way and show you that it comes out to be 4 squared of 5? It does, so. That's the only flaw. I think if these end up being the same, you're probably doing it right. So, okay, one more, and we are done with notes. I'm just going to do one more. Maybe you don't need one more. Maybe you caught on to it. But I'm just going to, we're going to find the sine of 2x. And I like writing the formulas down. We're going to find the cosine of 2x. Should we use a different one? Or do you want to keep working with the same one? Keep working with the same one or change it? Okay, care?
Same one.
Same one. We'll do the same one. Cosine squared x minus sine squared x. And tangent 2x. Sine over cosine. I took off 25 because, like, I'm waiting. These are the half angle ones, but these take a while because there's 3 parts for each one, so I only gave you guys 5 problems to do. And I guess this is the wrong page because I looked at my teacher's book. So I'll have to tell you what it is. But, okay, so first thing you're going to do is draw a picture in the 4th quadrant, right? Draw a picture in the 4th quadrant, which is down here. They're telling you that cosecant of x is a -4/3. That's the reciprocal of a -3/4. So sine is a -3/4. So sine, this needs to be a -3 and this needs to be the 4 then. And again, if you use the Pythagorean theorem, 16 take away 9 is the square root of 7. I don't know, I think one of the 2 problems, one turns out like all whole numbers, and I think the second one turns out to be a radical. Okay, so 2 parentheses, the sine of x is a -3/4. The cosine of this picture is the square root of 7 over 4. And then final answer, I guess this won't be the final answer. You'll find out why this isn't the final answer. The 2, the -3, and the square root of 7 are all in the numerator. That comes out to be a -6 square root of 7 over 16, 4 times 4. But that's not the final answer because you can simplify the 6 and the 16. 2 goes into there, right? -3 square root of 7 over 8. Final answer. Okay, this one. This is the cosine, so what happens when you square this? Aren't you going to get 7/16? Does everybody see that that's going to be 7/16 when you square it? Minus, well, here's sine. What happens when you square sine? Whenever you square anything, it's going to be positive, so don't even worry about the negative sign. 3 times 3 is 9, 4 times 4 is 16, 9/16. 7/16 take away 9/16 is a negative 2/16, which ends up being negative 1/8. And you're probably doing it right because your denominators are coming out to be 8s, or whatever the number is. So to find the tangent of 2x, I'm using the shortcut way. I'm going to rely on my first two answers. So I wrote down my first two answers. And now I'm just going to simplify it. A negative 3 squared root of 7 over 8 times a negative 8 over 1. Cancel out the 8s. 2 negatives equal a positive. Final answer, 3 squared root of 7. I'm going to say it one more time. I took the first answer, I divided it by the second answer. I took the division sign alone, I flipped it, the 8's canceled out, 2 negatives equal a positive. That's why I got 3 squared root of 7. Your assignment is, what, 7.4? 7.4.
Yeah.
454? 454.